All right, what's up, gang? My name's Zach Allen. I'm the founder and CEO of Slate Robotics, and you are tuned in to tutorial series number 5 on how to build a web development, a web platform for controlling the TR1. This is going to be all through the browser. It's going to be running on the robot, so you'll be able to control, manipulate, do whatever you want with the robot from a web browser. So you can use any device in order to control it, any web-able device. And yeah, it's really cool. Thanks for sticking along in the tutorial series so far. You may notice I've got a haircut since the last time. It's kind of a long story with that. It has to do with my wife cutting my hair. But that's a long story. I won't get into it. Yeah, so let's dive right into it. So I believe last time we left off where we got a lot of the front end figured out. And so we're still just building out the client and getting all that set up. So again, this is where we're trying to get to, and we are working towards that. Great. So what I'm going to do is I'm going to move myself down to here, and we're going to try to find the right. Yeah, no, that's right. Okay, so we are going to open up our terminal and server and all of that. So what I've got here, I have upgraded, yes, to Atom. I've installed that on Linux, so I don't have to use gedit. I've actually been much more serious. Like Ubuntu is pretty much my daily driver now. It's my go-to operating system. I had to use Windows the other day for doing some CAD work again, and that was not so pleasant. But that's something else we'll get into. So let's run, just so that we remember, our web server and run the back end and everything, get all that going. So what we're going to do on terminal tab number 1 is we're going to go into Control Center tut, and what we'll do here is actually do a ROS run TR1 Control Center tut, and oops, no, we don't want to do that. And we're just going to run the main executable, which is TR1 Control Center.js. And then over here on our other tab, we are going to ROS launch the server. TR1 Control Center tut Control Center sim.launch, because again, we're running this in simulation. Just a few more videos, and hopefully we can get to running this on the robot. See, the thing is, we build all of these great robots, and then we have to send them out to customers. So I've still got, let's see, robot cam. Where's my robot cam? No, there we go. So I'm trying to get all this figured out. So this is my office, and I've got my robot in here. This is still my prototype, like my first version I built in my garage like a year ago. So I need to get this fixed up and ready for prime time with our tutorial series. So once I get that done, we will be rocking and rolling. Okay, so we're going to ROS launch TR1 Control Center sim.launch. And remember, we've got a few arguments here for this particular launch file. Server is going to be equal to false, and we're also going to set GUI equal to false. We run this, nothing should show up. We'll get some output on the terminal here, and we should be good to go. Okay, ready to take commands for planning group left arm, and we'll run this over here, and we can see listening on port 8080. We can reload our page, and there we go. Cool. So this is exactly what we want. So we still have to build out all of the little terminals and stuff, not terminals, components on the front end in order to get this whole thing rocking and rolling. So let's jump right into it now that we've got this running. And again, we've launched this in 2 separate terminals so that we can very quickly close out of the server and rerun the server. Look how fast that was, right? We don't have to keep relaunching the same file, which is loading up the planners. It's launching Gazebo and all this different stuff. The shorter you can make your iteration cycle in anything you develop, the better. One thing I learned from building hardware with the robot like TR1 is that it's not like software, and where you come up with an idea and like literally a second later, you're able to test it and see if that works. Hardware is like you come up with the design, we're lucky to even have 3D printers these days. 3D print it, you wait a day, you get it back. That didn't work. The cycle time is very long. So this is making our development time much faster, which is great. So let's see which of these we're working through these JavaScript files today. Which of these do we want to tackle first? I think I want to be able to look around our simulated environment first, because we don't have that quite yet. So let's figure out where we should put this. So we're going to be having some sort of event listener where we can move. Basically, we enter a key command, and in fact, I think we might even have that here. Basically, we want to be able to enter a key command on the keyboard, and we have listeners that wait and see whether or not they should do anything with that, and all of that fun stuff. So I'm going to do something kind of quirky here, which is just to make it easy for our code, to make our code a lot cleaner. So this section right here, keys, we're starting a keys dictionary, and we're adding an event listener to windows.onKeyUp and windows.onKeyDown. And basically, we're just setting a property on this keys object equal to true or false, depending on whether or not that key was actually pressed or not. This is just making it so that whenever we get into our actual module that we're building, to where we're looping through this, we want to check and see if a key is actually being pressed. We can just do if keys, and then there's actually the codes and stuff. So let's assume that's an actual code that makes sense. We can just say, we can just do that, and that is keys 40. We'll say 40 is like, I don't know, the A key or something. It's not, but let's say key, and that way we can just check, okay, this key is currently pressed down, and we can run some code like that. It's much easier, in my opinion, to do it this way. So that's one slightly quirky thing we're doing. And then, right, I think that should be it. So let's see, we've got to decide now, where do we want to put our code? Now that we've got this key section, we can just basically check and see if the A key is being pressed, or the S key, or the D key, or something like that, to look around. We're going to use WASD to look around. Then we can, let's see, I'm inclined to say we should put that in the viewer. Let's see, but we might need to create our robot object first. All right, so I am back. So I have found actually where, how we're doing this. So we're going to have all of the code in the robot object, and we're going to have a few different functions that are going to check every time we run the loop whether or not there's been a change in key press, or whether or not the key is actually being pressed during that loop. And all we need to do from there is just then pass that. We'll basically set like a command variable within the robot object, and then we'll have an actual execute function within this .step. So we're going to start with that so that we can actually begin to look around our simulator environment. So let's create a state variable. So we're going to do, let's see. So we're going to do look. This will be where we keep track of our actual commands. And I believe these are probably going to be 0 to 100, or negative, I guess -1 to +1 for the actual command, right? So let's just quickly build that out if we could, and then we can go back and build some of the other stuff. We've got to make sure this actually works. So this function, this is gonna be our look function on the robot. So you can call this to actually move the head around. And we're going to set this.state.look.pan equals to pan. This.state.look.tilt equals to tilt. Var look equals this.state.look. And var, okay, so then we're going to keep track of the previous look here. I believe that's going to be used for a different part of the program. So plook is just the previous look. Was this state.previous look. So then we should probably go ahead and build out that here in our state variable, previous look, and then we can say, right. Okay, so the reason we do this is because every time we're doing a loop, right, of our within the program on the browser, we're doing this loop, constant loop, just keep going and going and going, and we're checking for changes in state and all that kind of stuff, and we have different events, and that's how the whole program runs. So what we've got here, by keeping track of the previous loop, is we can, let me just double check that I'm actually recording. Yes, I am. So what we're doing with that, by having that, is we're able to keep track of any changes so that if something does change, then we can actually send that to the server. And again, the whole point of that is so that we don't keep sending every time we loop. We don't keep communicating with the server. So we're communicating with the server as little as possible in order to just save on data, basically. So that we may only have to have, so if we just want to look left, we're just going to send the look left command, where we're going to pan in this direction. And then when you're ready to stop, it just sends the 0 to the server rather than 1 1 1 1 1 1 1 1 0, right? It's just going to be 1 0. So I suppose on decent internet connections, like, it doesn't matter that much, but this, why waste data when you don't have to? So we're just going to check if look.pan equals plook.pan and look.tilt equals plook.tilt. Then we're just going to return. Okay, but if that's not true, which would be, we don't even need an else statement there, then we're going to make sure that we're setting this.state previous look.pan equals this.state.look.pan, state.previous look.tilt equals this.state look.tilt. Okay, and now all we need to do is actually send that to the server. So I believe we should have jQuery and everything already installed. So all we need to do here is set up our AJAX options. So we're going to send this to the command route. This is going to be a post. Content type is going to be JSON, so I believe it's application JSON, and then the actual data. So we've got to stringify this in order to send this over HTTP stringify. There we go. This.state.look. So we're actually going to send the look object with the pan command and the look command. And data type equals JSON, and then last but not least is success function data. And way I've got this currently set up is that it returns the joint state, I believe. So that way we need to keep track of joints. Okay, make sure we've got our commas there. And who knows whether or not we'll actually keep this in the long run, but either way, we should be good. Now let's test it. Reload, and we've got an error, so let's check on that. console. Cannot read property, mouse pressed of undefined. Robot is not defined. Invalid left-hand side in assignment. So that's where our main error is. Where is that? It is line 15. Sources. Line 15 here, which is this. So we did one equal sign instead of equals equals, which is assignment versus comparison. Fixed. Okay. So we've got drop-down menu handle, mouse pressed is not a function. That might be preventing us from doing whatever else we need to be doing. So let's go to Sketch. So we haven't built that out yet. That's TBD, to be done. Okay, so we've got no movement. One thing we should check here, and I'll go ahead and make this smaller so that we can do some debugging a little easier. We can see that we're not getting any data on this server here. So I'm pressing the keys and nothing's happening. So let's go through and check our codes. We're doing new robot and then robot.step, and then so step we're not actually doing. Right, duh. Okay, so our step function isn't doing anything. So this is the actual thing that needs to be run. So what we're going to do, what we'll need to do is actually set up a separate function that checks and sees if the key is pressed, because we've got our lookup function set up. But to test that it's actually working, we'll just go ahead and send some data manually. And actually we'll go like that. And let's run our server and see what happens. Still nothing. This.look, we've got that going there. Track success. Okay, so console.log. So this is a good way that I typically use to debug these types of things. I guess the string is not really needed there. So I've got that, and I'm going to reload. I'm going to see if I get anything logged there. So it's all ones. Yeah, 1 0. Okay. So it looks like it's got sent once, but it's not showing up on the server. Oh, there it is. Post command look. Oh, okay. Never mind. So it is showing up on the server. Okay, so now we just need to see why it's not actually doing anything to our robot. All right, I'm back. Typically, how these things go, that's 2 problems so far this video, I'm sorry. Typically how these things go, yeah, you search, just right up until barely the point where you feel like your life has no meaning, and then you find the problem. It was simple. It was so simple. It was basically we were using the views. Let me show you how this file was set up initially. This was how it was before. This is the main router, like the highest level router in our server. And basically it was returning the views. It was having this catch-all route. So every bit of data was just getting posted to the views route, and it was returning the view rather than the command. So all I had to do here is just that. And now the router hits the command before it hits the views. Okay, so that problem has been solved. So now we go back to our robot function. After all that fun, we are finally back at it. Okay, so we can run this command, reload, and we can see it's looking up. Fantastic. Now all we need to do is just build a little section. So we've actually got data passed from the front end to the back end. Woo! All right. Who knows how long this video is going to be, because I've had to cut out so much stuff. Okay, so we are going to build in our robot section a handle click thing, right? So what I've got in my cheat sheet is to actually create a handle controls function on our robot object. And then on the step I believe we're going to do this dot handle controls, and then with look, we are just going to pass in this dot state dot look dot pan, this dot state dot look dot tilt. And so you might ask yourself, you might not, I don't know. But if you were me, you would ask yourself, why then are we passing the state as an argument here? And really, it's just so that if any other components that we're building out wants to use the look function, it's very easy. Because we could just technically not have that and then just automatically assign the state here and pass it through there, but this is how we're doing it. Okay, so with handle controls, there's going to be two basic. This dot handle controls, I believe look, yeah, look. This dot handle controls direction, which is going to be another thing that we won't get into, so we're actually not going to make that yet. Okay, so this dot handle controls. So we're going to have multiple controls. That just makes it an easy way to have your main and then kind of your sub functions. Function, and we're going to end up setting the look state based on whether or not anything's been pushed. Any commands. So this is, I mentioned those key codes before. Here's where we're going to store those key codes, 65. I think I had guessed, I had said that 40 was not A, and I was correct. 87 var s equals 83, var d equals 68. So these are the key codes for these keys. WASD, fantastic. And var look equals robot.state.look. I guess we can do this state. So we're just going to create our look object that we will end up setting, whether or not, based on whether or not anything's getting pressed. So if keys A is pressed, then we can do look.pan equals 0.9. And the reason I do this, it's not, you might ask yourself why not 0.9 instead of 1. You can set these values to anything you want between -1 and +1. But whenever we get to the tilt, we actually want to move slower on the way down than we do on the way up, just so that you're not, when you're looking, you can pan down a little easier rather than just going, or tilt down instead of just crash against the your like neck bone of the robot. So keys. Okay, so this is, we're doing S, and then, so if S is pressed, then we're going to pan that direction. If S is not, or if W is not pressed, or if S is not pressed, and if W is pressed, then we're going to do 0. Oh, I'm looking at the wrong thing. So A, which is left, right, and then D would be the other side of that. So then this would be -0.9. And then if none of them are pressed, we're going to default to sending a 0.0, i.e. stop command. And then we're going to do the same thing for W and S, except with tilt. W, S, S is going to be, well, W is actually our up, so our up is going to be 0.3. Actually, I think this is kind of flipped, so we have to send a negative command to go up. I believe that's how it works. We will be able to test this very quickly. So S would be down, that would be that. That's what I've got for my notes. I'm going to go with that for the second and not think about it too much. And then keys 32 is, yes, this is going to be spacebar. This stuff we can ignore. We're going to add actually a shift we're going to do where you can press shift and you can look more slowly. So we're just going to do look.pan times equals 0.75, and then look.tilt times equals 0.75. So we're going to just take 75% of the value there, and then yes, and in fact, just changing stuff on the fly here. All right, we're going to go in. Anybody following along just got very upset because I decided to change the look function to just be whatever the state is. There we go. That means this function doesn't actually have to return anything. And we can rerun our server, and something was not happy. So we're going to console.look, unexpected token, line 50, which is this right there. We had one too many of those brackets. Save, reload. More errors. Unexpected token. Obviously it would be down here because I copied and pasted. Save. I don't actually need to reload the server. And then, okay, so you can see we are extending the look command. Oh, right. Okay. Yes. So it does end up, and you can kind of see our wheels there. Aha! Fantastic. Okay. Well, this is great. This is great development. Okay. So, turns out that doesn't work. W ends up being down. It works. Okay, so we're going to leave it at that for now. Okay, so we've got the look function built out. I know I'm way over time here. These videos, my goodness. I think when I sit down and explain everything and I try to reprogram it and try to do a little tutorial, it ends up taking way longer than if I just sat down and programmed it. So I hope this is still fruitful for you guys. Unfortunately, I think we're going to have to end it from there. I am going to try to get way more focused on cranking these videos out on a regular basis. I know last time I had mentioned that I was going to do that. It's hard when you've got robots that need to go out the door. That takes priority. But I appreciate you guys sticking along and sticking around for this. So we will come out with the next video where we'll talk about how to drive around or do that kind of stuff. But we finally got our backend server accepting data. We've got it sending it to Ross. We've got being able to look around on the front end. So we've got a lot of great progress. So thanks a lot for watching. Be sure to subscribe. Be sure to order a TR1 if you are at all interested in robotics. And we'll see you guys next time. Thanks.